Okay, all right. I think let's do it. Righty then, guys. What I'm going to try to do in this small video is do a little bit of the review on pertaining to circles. So why don't we go ahead and get started? Okay. Let's try to make this quick and to the point. So let's start off with the equation of a circle that is center at 0, 0 with the radius of r is given by this equation. So the center will be 0, 0, and the radius will be equal to the square root of r squared. Okay, so for example, if we have x squared plus y squared equals 25, this would be a circle that is center at 0, 0 with the radius of the square root of 25 is equal to, in this case, 5. So maybe I should say here that this will be a radius of r. Let me just make it like so, with the radius equal to r. Okay. All right. So, well, I think let's do one more example. Let's do x squared plus y squared is equal to 17. Well, in this particular case, the center will be 0, 0, but the radius will be the square root of 17. And this is as good as it's going to get. We're not going to be able to simplify this any further. Okay? But then we started talking about circles that are not centered at 0, 0. And therefore, this will be the equation that we use when a circle is centered at some other point other than the origin. And so the radius, once again, the radius will be equal to r. So let me show you an example. So if we have, let's say the equation x minus 5 quantity square plus y plus 3 quantity square is equal to 81. This is the equation of a circle that is centered at 5, negative 3 with the radius of the square root of 81, which is equal to 9. Notice that in this case, the equation, and what I'm looking at is the negative 5 and the positive 3. The equation and the center of the circle have opposite signs. Okay, and what I've been saying in class is the reason for that is because there is a minus here in the formula. So therefore, those minuses change the sign. So let's see. Let's look at another example. Let's say that we want to write the equation of a circle that is centered at negative 7, 10 with the radius of, let's say 11. Okay. So therefore, by the formula, we have x minus h quantity square plus y minus k quantity square is equal to the radius square. Negative 7 will be h, 10 will be k, and of course the radius is 11. So we have x minus, that's from the formula, then h is negative 7 quantity square, y minus, again from the formula, 10 quantity square, 11 square. Cleaning this up a little bit, we get x plus 7 quantity square plus y minus 10 quantity square. And if my math serves me right, this is 121. Once again, the biggest difficulty here is remembering that the connection that there is between the formula of the circle and the values of h and k. There will always be opposite signs. So to do one more example here, if we have a circle as x plus 1 quantity square plus y minus 3 quantity square is equal to 72, then the center will be, well, the opposite value of plus 1 is negative 1. The opposite value of negative 3 is positive 3. And the radius is the square root of 72. But don't forget that this can be simplified. And so therefore the square root of 36 will be 6. And there's nothing we could do with the square root of 2. So therefore that will be that on that. Okay. Okay, so now let's talk about a slightly more difficult concept that we did with circles. And let's see. Let me pause this real quick. Let's see if I can do this. All right, so let's look at now at what is referred to as the general formula of a circle, which is given like so. X squared plus y squared plus dx plus ey plus f is equal to 0. In this case, d, e, and f are real numbers. So the difficulty with this is that although we might be able to write an equation, we won't know what the location of that circle is or how big that circle is. So the idea is that we want to go from the general formula to the center radius form. And then we can have a little bit more information about what that circle looks like, where is its center and what is its radius. So let's go ahead and do an example here. And we have the following. X squared plus y squared plus 6x plus 8y plus 9 is equal to 0. Okay, so in order to do this, okay, we are going to remove the constant and we'll get, now watch this, x squared plus 6x. Did you notice that I started to rewrite the x terms together? Hopefully. Plus y squared plus 8y is equal to -9. Did you also notice that I purposely left a gap between the 6x and the plus sign and the 8y and the equal sign? And the reason for that is because I am going to place a number here and a number there. Okay, and I'm going to show you how to get that number. But first, let's go ahead and group the x terms together and group the y terms together. And so the idea here is that I would like to complete the square. And so I would like to complete the square x squared plus 6x plus some number here that will complete this square. To do that, this will be the value of b in this trinomial. So we're going to take b, divide by 2, and then we're going to square that quantity. What is that? 6 divided by 2, quantity square. 6 divided by 2 is 3, quantity square is equal to 9. So the number that completes the square is 9. And so if we add 9 here, we must also add 9 to the other side. Let's complete the square on the y terms. We have y squared plus 8y. Again, we have this blank. We take 8, which is the b value, divide by 2. 8 divided by 2 is 4. 4 squared is equal to 16. So in this case, the number 16 will complete the square. Why do we do that? We do that because this trinomial is now factorable. So is this trinomial. And so this factors into x plus 3 quantity square plus y plus 4 quantity square. And on the other side, we see that the result is 16. voila, we have taken this equation that was in its general form and we have transformed it into the center radius form, because now we can say that the center is -3, -4, with the radius of the square root of 16, which is equal to 4. Okay? Let's do another example. Let me pause this first so that I can clean. Oh, no, I think I could do it like that. Okay? All right, so what I'm going to do is I'm going to clear the ink and I'm going to do another example. Okay? All right, so here's another example. And we have x squared plus y squared plus 8x minus 6y plus 16 is equal to 0. Okay, so once again, we need to transform this that is in the general form into the center radius form so that we can identify the center and also tell what the radius is so that we can know how big it is. Okay. Now, before I move on, because this might show up in other examples, the radius, in order for this equation to be a circle, the radius must always be greater than 0. That will be a circle. So you're probably wondering, so what happens if it's not equal to 0? Let's say, what happens if the radius is equal to 0? That's not a circle. That shape is just a point. Just a point. And if the radius, when we do our math, turns out that the radius is less than 0, this graph does not exist. Okay? So in the previous example, we found our computation revealed that we found a center and the radius was greater than 0, so that equation makes a circle. But we could run into examples where we do our algebra, we do all of our computations, and then we recognize that, oh, wait a minute, the radius is 0. That is not a circle. That must be a point. Oh, wait a minute, the radius is less than 0. That cannot happen, so therefore this graph does not exist. So let's go ahead and do this example and let's see what can we run into. The first thing we'll do is we'll move this 16 out of the way. It seems like it's not really doing much over there, so we'll remove it from the left side. And at the same time, I'm going to start rearranging the equation by writing the x terms together and the y terms together. Did you once notice that I left a gap between the 8x and the plus sign? Did you also recognize that I left a gap between the -6y and the equal sign? And the reason for that is because we are going to write here some numbers that will complete the x squares, and we are going to write here a number that will complete the y square. What are those numbers? Well, let's see. Well, I'm going too fast. Let me take it back. I wanted to write x squared plus 8x plus, what is this number? We'll take 8 divided by 2 and we'll square that. That will be +4 quantity squared, which is equal to 16. So 16 will be the number that will complete the square. But wait a minute, we just added 16 on this side. We must also add it on the other side. Okay? All right, let's complete the y square. Y squared minus 6y, and we need a number here that will complete the square. That is -6 divided by 2 is equal to -3 quantity squared, which is equal to 9. In this case, the number 9 will be the one that completes the square. And I know I could see it. I know you're eager to do this. I know the 16s will cancel out and we'll just get 9 on the right side of the equation. We did this, or this procedure of completing the square, because this is factorable and it factors into the following. Okay, just let me go a little bit slow here so that you understand it. 4 times 4 will be equal to 16. Also, 4 plus 4 will be equal to 8. So this factors into x plus 4, which is the same as x plus 4 quantity square, plus negative 3 times negative 3 will be equal to 9. And negative 3 combined with another negative 3 will be negative 6. So this factors into x minus 3, y minus 3, or y minus 3 quantity square equals 9. Therefore, I'm looking at this number here. Okay, I'm going to say that for just about 2 seconds, the center will be negative 4, positive 3. And the radius, since this number is positive, okay, will be equal to 3. This must be a circle whose center is negative 4, 3, and with the radius of 3. Okay? All right. I am going to do one more example on this, and one that does not. It's something other. We get something different. So let's look at this example. Okay, and this will be my last example, and then look for another video, and hopefully this is a little bit more help than what we did in class. All right, so we got the following equation, and let's assume that we don't know what this is. Well, actually, we don't know what it is until we start doing the math. All right, so plus 14 is equal to 0. So in this case, minus 14 minus 14. Again, as I write this next sentence, I am going to start rearranging the x terms together. I'm also going to arrange the y terms together. Notice that this constant gets moved to the other side. We're going to find the number that completes the x squares. And then we're going to find the number that completes the y square. The number that completes the square here, that will be 2 divided by 2 quantity square. That will be 1 quantity square 1. So therefore, the number that completes the square is 1. But since we added a 1 on the left side, we must also add a 1 on the right side. What is the number that completes the y square? That will be negative 6 divided by 2 quantity square. Negative 6 divided by 2 is negative 3 quantity square, which is equal to 9. So the number that completes this square is 9. Don't forget to add 9 to the other side. So when I'm saying this is, I'm pointing here, this is factorable. So is this, okay? And this factors into x plus 1 quantity square plus y minus 3 quantity square is equal to, this will be 10. 10 minus 14 is negative 4. This is where I begin to wonder, do we really have a circle or do we have something else? And so, okay, we might say that the center is negative 1, positive 3. Very common to try to go through that process. And then we do, the radius is the square root of negative 4. Well, that is 2i. This is imaginary. How can a circle have an imaginary radius? That makes no sense. So therefore, it implies that this equation this graph does not exist in the rectangular coordinate system. Remember, the rectangular coordinate system has two real axes, the real x-axis and the real y-axis. So there is no way that we can plot, okay, or graph that the point or the length 2i. It doesn't work out. It just doesn't work out in the rectangular coordinate system. Okay. All right. Hopefully we found a good review out of just circles, and hopefully use it if you had some misconnections here. I hope it helped out. All right. Y'all take care. Bye-bye.